Hello and welcome to 5.10, Urbanization. And here we're going to talk about the movement of people into urban areas from rural areas, and then out of urban areas into suburbs. Interesting. Let's see what we got. So we're going to talk about urbanization on the environment and its effects, and there are many, as usual. We're going to talk about depleting resources, mostly in the form of metals and petroleum products, fossil fuels. We're also going to talk about salt water intrusion. That is the actual movement of salt water into a water supply that we would normally use for drinking water, and its effects in the hydrologic cycle, aka the water cycle. We're going to talk about burning fossil fuels in terms of construction equipment, landfills, and how all of those things will add more carbon dioxide to the atmosphere, further increasing global climate change. We're going to talk about something called an impervious surface. That may be a new word for some of you, aka does not let water in. Things like roads, buildings, and sidewalks, parking lots, and such. And when water cannot get in, it's going to run off, and water that does not sink into the ground cannot return to the groundwater supply or drinking water supply, which again could lead to major problems. Also, that runoff is going to bring pollution and other chemicals into larger nearby bodies of water. And then we're going to talk about what urban sprawl is. And this is when the people move into the urban areas, the city areas, they realize that it's way too packed, and then they want to get just a little bit outside of that urban area. And those places are called the suburbs. So we're going to talk about the moving in and the moving out of people. So urbanization is very simply removing the vegetation that was there and convert it into a cityscape, otherwise known as an urban environment. And if you have been to New York City, with the exception of Central Park, there is not a lot of natural vegetation there. You're going to replace that soil, vegetation, and wetlands, and we learned a lot about wetlands in the biome section and how important they are. And you're going to replace those things with these impervious surfaces, this concrete, this asphalt, cement, and that does not allow water to infiltrate into the ground. And if you can't recharge that water, we're going to see problems moving forward. On top of the water problem, there are tons more CO2 emissions in the form of the cement production for these buildings, the foundations of these buildings, the buildings themselves, some of them are made out of cement, and the roads and the bridges. The construction machinery is going to burn tons of fossil fuel. Deforestation, it's a double whammy. You're losing those trees' ability to sequester that carbon or hold that carbon we talked about. And at the same time, all that dead tree material that they don't use will decompose, and those decomposes will add CO2 to the atmosphere. And then you have to throw all this junk out into landfills, and in some cases they burn the material in the landfill, which again also releases CO2 into the atmosphere. So urbanization is causing a lot of problems. In the case of runoff and groundwater recharge, that's a big deal. So typically, if you look on the picture on the left, when it rains, there's evaporation, of course, and a little bit of runoff, 10%, and a fair amount infiltrates the ground, whether it is deep or whether it is shallow. Your shallow infiltration is going to be picked up by trees and grasses and things, and your deep infiltration will make it back to the groundwater. If you look at the picture on the right, evaporation doesn't change too much, but infiltration decreases big time, especially that deep infiltration, that recharge to the groundwater, an increase in runoff of 55%. That is huge, 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 huge. So this urbanization once again prevents groundwater recharge, big word, because we pull water out all the time from the ground for drinking and for watering our crops. And if it's not getting back into the ground, major, major problems. Well, how can we at least try to stop this? And in some city areas, if you walk around enough city areas or in some of the newer kind of urban areas that are taking off, you're seeing something called permeable pavement. And it's just a fancy way of saying instead of using straight cement or asphalt, you're going to use pavers. Now, if you know what a paver is, you may have them on your driveway. And a paver is a shaped stone, and they fit together pretty close, but not perfect. And those little gaps in between them will allow water to sink in. Now, obviously, some will run off, and it's not going to be zero, but at least it allows some more water. It's slow, but it will allow that water to infiltrate back into the soil. I'll show you a picture of it in a second. It's better than a driveway or a road. Now, in the most cases, you're not going to use these pavers on something like Sunrise Highway or Southern State or the LIE. You're going to use them in lower traffic areas, places like parks where there may be walkways for people, or some people may have them in their driveway. Those are the places you're going to use this, not your major superhighways. And if you look at this picture, it starts off with these concrete pavers, which again are shaped stones, which allows water to infiltrate in. Another important word is this coarse kind of grained material, and coarse means large, so that's going to also let the water sink in. And then there's going to be some kind of under drain, and that's going to catch some of the water and allow it to run where it needs to go, or at least direct it where you'd like it to go. But it also has holes in it, which will allow the water to sink in slowly and return to the ground. So it's kind of the best of both worlds. So that is permeable pavement. So let's take a look at a little math, because this is how they're going to package this. They're going to tell you about the permeable pavement. They're going to tell you about the runoff and the infiltration. But then how do we apply it? So in this case, I want to know what is the increase. Now, these questions, you have to read them very carefully. The increase of the shallow, 25%, versus the urban, only 10%. So 25% is a lot more than 10%. So when you set up your math, you're going to set it up like this. You're going to have the new number minus the old number over the old number. So they're asking the natural versus the urban. So your new number is going to be 25%. Your old number is going to be 10 over 10 times 100. So 25 minus 10 is 15. 15 divided by 10 is 1.5 multiplied by 100. And you will have 150% increase in the shallow setting, a shallow water infiltration in a natural setting. Well, let's see another math problem. What percent decrease in deep infiltration? So now you're coming this way. Now you're going from 25% down to 5. So that's a huge drop. So how are we going to do that? New minus old over old. Now, in this case, it's going to be a negative number, so negative means decrease. So 5 minus 25 is 20, divided by 25. Now, again, it's a negative number, so you know it's going to be decrease. And you will see an 80% decrease in the urban setting. 80% is huge, 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 huge. Now, if you're a math person, anytime any number decreases, and we're going to practice a lot of this, a decreased number can never be more than 100%, but an increased number can. So if an increased number is 150 or 200 or 500%, that's like doubling, tripling, and so on. When you decrease, it can never be obviously more than 100%, because 100% decrease would be down to 0. But 80% you can see is most. So you started at 25, you're down to 5. That's most of the number. And we will practice a lot of the math, but just remember your formulas. New minus old over old times 100. Just remember those formulas. So, urbanization in coastal cities. Everybody wants to live near the coast. The population in these coastal cities is growing, of course. But when you're near the coast, you're going to need water. So let's say you had this nice, beautiful tree and everything was all good. And you have this thing called the water table, and that's where fresh water is. And if you tap into it, you can drink it. But now you put a whole bunch of stuff, a whole neighborhood or whatever, near the coast. So you put a well into the ground. And what a well literally does is taps into the fresh water and pulls it out of the ground so you can drink it or you can water your plants. But when you're near the coast, if you pull out too much water, when you remove water, it's going to replace itself with other water. It just doesn't replace itself with nothing. And where there was a fairly large distance over here away from this salt water, and that's set up by density as well. Salt water is more dense. Now the salt water has kind of replaced that fresh water you pulled out, and that's known as salt water intrusion. And if you start pulling salt water up your well to water your plants or to drink from, your plants will die and you will get sick, and potentially you will die because salt water is not drinkable by humans and most plants don't like it. So excessive groundwater withdrawal near the coast is going to lower that water table, and it's going to allow that salt water to seep in. And again, that could be very, very bad. What about sea level rise? That's also going to be a problem. So you have your homes and you have them near the water and their well is working fine. And little by little, the sea level changes and you're pulling all this water out. And before you know it, the salt water finds its way into that well. Not good. And the sea level rise is due to, as you know, the warming of the ocean and the melting of the ice. And what you may see is what's the term thermal expansion. And when water warms up, it kind of expands a little bit. And we'll talk more about that when we get into the science of it later on in the course. And of course, the melting of ice caps is increasing ocean water volume. All problems. What about, so now we talked about the infiltration, the runoff. We talked about the nearness to the coast. What about just if you're kind of, in Missouri? Well, what are the trends in populations in places like Missouri? Well, there's a lot of rural areas, a lot of farmland and such. And people are moving from those rural farmlands into these urban areas, into these cities. And they're moving there for jobs and entertainment and cultural attractions and all the fun things that cities have. But what happens is now they are super densely populated. And people are like, now there's way too many people. So then they kind of start to move just out of these urban areas into what are known as the suburbs. And you currently live in one of those. So what's going on? Well, there were a fair amount of people in these rural areas and not too much urban, not too much suburban, because again, they just went right to the cities. But in the last just 50 years, according to this chart, you can see your rural kind of went down a little bit. Your urban kind of jumped a little bit. But suburbs, where you live, that trend went crazy. So the overall trend in the U.S. and many other nations is to now get away from those less dense areas and move towards these urban areas. And then they get too full, and then we move out to the suburbs. So crazy, crazy, crazy. But places like Nassau County and Suffolk County. And I live in Suffolk, you live in Nassau. The further out you come by me, things get a little bit more spread out. So what is this urban sprawl? What does it all mean? So that's the population all moved into the cities, and now they're like, forget it, it's crazy. So now they're moving out of these dense urban centers, these less dense suburbs. So basically people are moving from Manhattan out to Queens, out to Nassau, out to Suffolk. Now there is a point when far is just too far. And how do we make the far not too far? Well, we build better roads, we build better bridges, we build a better system of mass transit, we get trains, we get subways. And all of those things makes it easier to get from those suburbs into that urban area. Why do people also move to the suburbs? Cheaper property. I mean, you could pay $2 million for a one-bedroom apartment in Manhattan, or you can spend 1 million or less and get a beautiful home out here in the suburbs. And because cars make it super easy, people just get in them, and mass transit helps. Well, what happens in these urban areas? Well, people leave. And then everyone's like, oh, they're leaving and they got a beautiful home. Maybe we'll leave and we'll get a beautiful home too. And now there's less people living in the cities. Now there's less tax revenue. There's less people paying taxes. Less services, less bus service, less train service. Everything kind of falls apart. Businesses are like, well, let's go out to Nassau too, because our rent is, quadruple here in the city. We can move out to Nassau or Suffolk and save a ton of money on rent. And then the worst thing of all happens. Now there's just abandoned buildings, abandoned businesses, and you get this thing called blight. And it's this unsightly, rundown infrastructure when people leave. And that's when these parts of the city become really dangerous. And that's when a lot of, less desirable situations end up occurring. So that is what is, currently happening in some large cities. And the reason why they make it easy is these highways. It makes it super easy to drive. And there are more taxes on cars, which makes it more money for roads, and they make more highways and more bridges. And now you have more bridges and highways, and it's super easy to get in and out of the city, with the exception, of course, of New York City, which it costs a fortune to do that. But in all of these areas that are not New York City, where you can simply drive into a city without having to go over a bridge, life is good. And if you want to see a crazy urban sprawl area, just look at Charlotte, North Carolina. And the outskirts of Charlotte, there was nothing there 20, 30 years ago. Now it is just crazy. So if you want to see suburbs gone wild, look outside of Charlotte, North Carolina. Well, what can we do? Well, we can have what are called urban growth boundaries and have these zoning laws set up by the city. And within the city, make it easy to get around, kind of spread things out. And then you'll hear a lot of this mixed land use, especially in these new projects that they're talking about. So they might take a rundown area of New York City and they're going to put housing and they're going to put a transportation hub and they may put some sort of arena and they may have a mall. And if you put everything all together and you make it kind of reasonable to live there, people may come back, and that will kind of bring them back to the urban. So this is an in and an out story. So putting it all together, describe a possible solution to the issues of urban sprawl and then one possible economic consequence of the solution. So that kind of ties into the entire unit. So think about that, and I'll see you next time.